Okay, Ellie, we're going to try to talk through a pretty tough problem here. I think I can do this with the software I use for teaching, but you'll have to tell me how good this comes through. So the first thing is note that they're saying find f double prime, which is the second derivative of f of x. And then they're using something that we worked on last Sunday. We have f of x is equal to x times, and then we have an exponential, but it's not base e, it's base 6, and it's 6x squared plus 3. And so the first thing that I've tried to note here on what I've numbered my lines here, line 1, is that we're going to have to use the product rule for these two different parts of f of x. And so I'm writing out first just the general expression in line 2 that f of x, I'm going to allow that to be a function that's a product, h of x times g of x. And then if that's the case, then f prime of x is equal to h prime of x times g of x plus h of x times g prime of x. And this is going to be, for the case that the problem that we're giving, we're going to let h of x equal x and g of x equal 6x squared plus 3. And so, and in line 4, we just note that we need to look at the second derivative. And so what that means is that we have to take what we developed in line 2 and we have to take another derivative. And that's kind of the tricky part of this problem here. So in line 6, I write out f double prime of x is equal to h double prime of x times g of x. It's the same thing that we're doing before. It's just one of my functions now is either h prime of x or g prime of x. But it's the same product rule. You just have to hold one function constant, take the derivative of the other one, and then add the opposite, which is the derivative of the whichever one you had just held constant times the original other function. And so you get line 6 here, which you can go through and look at, but that's just the product rule applied a second time to the two different parts of f prime. And then in line 7 and 8, I say h of x. I'm gonna write out what the different parts of line 6 are in terms of h of x, h prime of x, and h double prime of x. And h of x is equal to x, which means that the first derivative is just equal to 1, which is a constant, and so the second derivative is going to be equal to 0. And the more tricky part is g of x. I'm going to let g of x equal 6x squared plus 3, which means that g prime of x is going to equal, and then remember that when it's not base e, you have to take the natural log of the base, which is 6 in this case, times the derivative of the exponent, which is just 2x, times whatever the exponential is just carried down, and this is 6x squared plus 3. So that is what g prime of x is. And so now it gets a little bit more tricky because I have g of x, I have g prime of x, but you'll note that at least once in line 6, I have to write out what g double prime of x is. And so now I have to use the product rule again for my g prime of x to get g double prime of x, and that's line 11. Okay, and so first thing, note that g prime of x, the natural log of 6, that's just a constant, so I pull it out in front. And I'm going to use the product rule. And so I'm going to take the derivative of 2x, that's just 2, which you see here, times, I'm going to write the exponential all over again. And then I'm going to add, because we're applying the product rule, I'm going to add the quantity 2x times, and then I'm going to take the derivative of that exponential, which gives me the natural log of 6 times 2x, and then it's kind of crammed here on the side, but it's just 6x squared plus 3. And so in line 12, I just noted that line 11 was kind of messy and crammed, and so I went ahead and wrote it again, but I also noted that I can pull out this exponential 6x squared plus 3 from the parentheses, which gives me this inside of the parentheses. And in line 13, I really just squared the 2x. And so inside the parentheses, I have a 4x squared. And so line 14 is just pulling it all together. So we're taking what we wrote in line 6 here, and now we have all the different pieces of h of x, h prime of x, h double prime of x, g of x, g prime of x, g double prime of x. And we're going to substitute those in. Now I note that the h functions are easy. And so I substitute them in here first, and note that h double prime of x is equal to 0. So that's going to kill that first term, that first product term. H prime of x is equal to 1, and that's used twice here, and then h of x is just equal to x. And so now in line 15, I just make the substitution in for the h of x values, and it is now just a function of g of x. And now I just substitute in the g of x, g prime of x, and g double prime of x. So this is just substituting in at this point, and you get line 16, which is the answer to this really challenging problem. And so what we see here, like what are the principles that we used here? One, we used the product rule about 4 times in this, and so tremendous attention to details required with that. We also learned about taking the exponential of, or the derivative of an exponential where the base isn't e, and in order to do that, it's just like we did with the natural log, or excuse me, with the exponential, but we have to multiply the whole thing by the natural log of whatever the base is. And so that's an important piece of this. And then, as always, we use the chain rule, which, for the exponentials, require that you take the derivative of the exponential and then you multiply it by the exponential again. So anyway, I hope this helps, and we can talk through this if you have questions. Okay, Ellie, now that you survived problem 1, which is one of the hardest calculus problems I've done in a while, you're going to be disappointed that problem 2 is so easy. So here, just like we talked about on Sunday or Monday, the key here is getting the substitution right. We're trying to solve the integral of, and then the integrand is going to be 3 raised to the square root of x power. That is all divided by the square root of x, and that's multiplied by dx. So just to review, the integral here, this is the integral sign, the elongated s. The differential is the dx, and then the integrand is what's in between the integral and the differential here. So we need to make the right substitution, and because I sort of noticed a pattern, I'm choosing to use u is equal to the square root of x. And the reason why I know that is because I knew that when I took the derivative, I was going to end up getting 1 over the square root of x, and I just noticed that that was right here in the denominator. And so du is going to be equal to 1/2 x to the minus x dx. That's just taking the derivative of line 1 here. And I'm trying to get the differentials to line up. And so what I notice, so in line 3, I just bring the x into the denominator here. And in line 4, I just write the exponent as just the square root of x. And then in line 5, I notice that I need to multiply both sides by 2. So I get 2 du is equal to dx divided by the square root of x. And the reason why is up here, if the original problem, I know I'm trying to get dx over the square root of x. And so I need the substitution that gives me that. So I go ahead and I make my substitution in line 6 here. And that's going to be the integral of 3u times du times 2. This 2 is a little awkward out here. I mean, in the next line, what I do is I just pull it out in front of the integral, which is probably what I should have done all along. And so then you're left with 2 times the integral of 3u du. And you remember that when you take a derivative of an exponential and the base is not e, you have to multiply it by the natural log of the base. So when you're taking the integral, it's the opposite. So instead of multiplying by the natural log of the base, you have to divide by the natural log of the base, which is in line 8 here. You get 2 divided by the natural log of 3 times 3u plus a constant. And if you want to check to see if you've done the integral right, you just take the differential, and you'll note that the natural log of 3 will cancel out with the natural log of 3 that comes from differentiating 3 to the u, and you'll just get this the line above that you started with. And so after we go to line 8 here, and all this is on the right side of the page, lines 10, 11, 12, and 13, it's just me showing that like a little more carefully that you need to divide by the natural log of 3. But I may have actually made it more complicated than it needs to be, because I think just explaining it as being the opposite of the derivative is probably the easiest way to look at it. So in line 9, I just write my original integral to the right, and then now I resubstitute in the value of u equals to the square root of x, and presto, that's the end of the problem. And I know you're really disappointed because after problem 1, you're probably totally hyped up and wanting to do the product rule 5 or 6 more times, but unfortunately, that's all there is.